I forgot to write out these two numbers are in here. Sorry about that. The two numbers are max 1 comma absolute value of a naught plus a1 plus dot 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 an minus 1. And 1 plus the max of all these numbers. Okay, this seems really confusing. Max means the highest number in this set. It'll make more sense when I do an example. Alright, so A, find a bound to the zeros of each polynomial. In this polynomial, the leading coefficient is 1, so we can use this. Sorry about that. So the max between 1 or 3 plus negative, or the absolute value of 3 plus the absolute value of negative 9 plus the absolute value of 5. Okay, so we've got max 1 or 17. So you look and go, okay, which is the bigger number? 17. Alright, that's the first number. The second number is 1 plus the max of each of these numbers. So absolute value 3, absolute value negative 9, absolute value 5. The highest number in here would be the 9, so I've got 1 plus 9, which is 10. So 17 and 10, the smaller of the two numbers, is 10. Alright? Okay, for B, we don't have a 1 as a leading coefficient. So what I have to do first is I have to divide everything by 4. So now I've got x to the 5th power. 2 over 4 simplifies to 1 over 2. And the same thing with the third term. Oops. Plus 1/4. Okay? And then we just do the same thing again. Max of 1 or 1/2 plus 1/2 plus 1/4. Oops. So the max between 1 or, this would be 1 plus 1/4, so 5 over 4. 5 over 4 is a little bit bigger. Alright, so that's the first number. The second number, 1 plus the max between all these numbers. The biggest number is 1/2. So I've got 1 plus 1/2, which is 3 over 2. The smaller of the two numbers is 5 over 4, because 5 over 4 is 1 and 1/4, and this is 1 1/2. Alright. Obtain a graph for each polynomial. I'm going to have you guys skip these next two examples. It's pretty much just more of the same thing. If you want to do them for extra credit, that's fine. Just let me know that you do them and I'll give you some extra credit. Alright, intermediate value theorem. Alright, the intermediate value theorem says that if you let f denote a continuous function, if a is less than b, and if f of a and f of b are of opposite signs, then f has at least one zero between a and b. And if you think about it, this kind of makes sense. So if you have some continuous function, I don't know, could be anything, like that. And let's say this is a and this is b. What I mean by that is that the x values are a and b. Let me rewrite that. So, here's a, here's b. And if A is negative and B is positive, like the y values, if you plug in A, you get a negative number, you plug in B, you get a positive number, then obviously at some point it has to cross the x-axis in order to get from negative to positive. So there has to be a 0 between A and B. So if you just have to prove that there is a 0, all you have to prove is that somewhere along the way there is a positive and a negative number, or a negative and a positive number, and you've already proven that it crosses the x-axis. Okay? I'm not going to do this one because this is a continuation of example 10. I'll do this one here. Use the intermediate value theorem to show that the function has a 0 in the given interval. So, let's just plug in the values. If you plug in negative 5, 2 times negative 5 to the third power plus 6 times negative 5 squared minus 8 times negative 5 plus 2. Sorry. Negative 5 cubed, that's like negative 125 times 2 is negative 250. This is positive 25 times 6 is, oh goodness, 150. This gives you 40. This gives you 2. And if you add all this together, you end up with some negative number. It's negative 100 plus 40 is negative 60 plus 2 is negative 58. Now let's plug in negative 4. 2 times negative 4 cubed minus 6, plus 6 times negative 4 squared minus 8 times negative 4 plus 2. Negative 4 cubed is negative 64 times 2 is 128. Sorry, negative 128. This is positive 16 times 6 is 96. Plus 32 plus 2, and you can kind of already see that this is going to give you a positive number. Let's see here, 96 plus 34, that's 130, so you get a positive 2. This is negative, this is positive, so we have proven that that by the intermediate value theorem, there is a 0 somewhere in this interval. All right.